Well, for 6.4a, I went to see his lecture notes, and unfortunately, he did not post them correctly. What's there, if you're able to see it, is 6.3b again. And so I thought a great way to handle 6.4a, the only 6.4 section that we're going to be handling, is to just look at some examples together. You have all the skills that you need. So let's take a look, and we'll just do a few together, and then I'll leave the rest for you to do for homework. This is typically what I would do in my class. Have some instruction, but then go over and make some videos over how to do homework examples. So let's take a look at number 1. And number 1, I'll still write in blue so that it looks a little bit different. So number 1 wants us to take 2 sine x plus 3 is equal to 0. Now notice what it wants. It wants all solutions on the interval 0 to 2 pi. So we're not going to be doing that 2 pi k thing or pi k thing that we were doing in the previous section. We only want the solutions on a small interval from 0 to 2 pi. And so let's take a look at how we would do this. Well, what you're going to do, step number 1, is you're going to solve for the trig equation. Or the trig function, sorry, I should say that differently. So let's do that. Let's go do step number 1 over here. If we do that, we get 2 sine x, and I'm going to move over the root 3, so it's going to become negative. And then I'm going to get sine x is equal to negative root 3 over 2. And so your answers should be in radians like it's specifying there. X always represents a real number. And so we're then going right back to the previous section, asking ourselves, when in the world for what angles is sine theta equaling root 3 over 2? So let's get that reference angle. I know that sine of pi over 6 is 1/2. So I know that this is a pi over 3 reference angle for number 1. Now, I need to make sure it's in the right quadrants. It needs to be negative. Well, where's sine negative? Sine is negative in the 3rd and 4th quadrants. So I need to name the answers of 4 pi over 3. And then also in the 4th quadrant, where would that be? That would be pi over 3 back from 6 pi over 3 or 5 pi over 3. Those are the two at times that you would, two angles, 2 times between 0 and 2 pi, that equation would be solved. So it's solved whenever sine x is equal to negative root 3 over 2. So you're just doing a little bit of algebra manipulation in order to come up with that. And I believe, we can check our answers at the bottom, right? He has all the answers on the last page. Oh no, he has them on a different thing, right? So you can see all the different type of work that we're going to be doing. So let's just hop down to something like, let's take a look at something like number 3. If we go right underneath that and we say, hey, root 2 sine x minus 1 is equal to 0. Let's solve for sine x. So I would move over the 1, divide by the 2. This isn't the form we're used to seeing it in. But we should know that sine of a pi over 4 angle is root 2 over 2. I believe I have the correct sign of it being positive, positive root 2 over 2. And so where is sine positive? We remember from above, it's positive in the 1st and 2nd quadrant. So one of the angles is pi over 4, and the other one is pi over 4 back from 4 pi over 4 or 3 pi over 4, and we're finished. If we hop down to something like number 6, it looks a little bit crazy. Well, what's that look like? It's already factored. Well, if you have a product of things equaling 0 from your beginning algebra days, either, and I'll make this bigger, right? I can make that really big for us. Either the first thing is 0, or the second thing is 0. And so we need to name the times that this guy, or the angles that will work. So it's angles that either make the first thing 0 or the second. Let's work on the first. So I would move over the 1 and it would be negative, and I would divide by 2. Now I have memorized that sine of pi over 6 is 1/2. So it's a pi over 6 reference angle where sine is negative, and sine is negative in the 3rd and 4th quadrant. Right? All students take calculus. And so 3rd quadrant angle, 7 pi over 6. Fourth quadrant angle, 11 pi over 6. Those are the two solutions from the first one. Cosine x equals 1. 1 means I'm on an axis. Cosine corresponds to the x-coordinate. And I need an x-coordinate to be 1. That's here at 1, 0. Right? Remember, this is 0, 1. This is negative 1, 0. And this is 0, negative 1. The only time I have an x-coordinate equal to 1 is right here. And so between 0 and 2 pi, it's 0. So the three answers are 0, 7 pi over 6, and 11 pi over 6. You'd want to get them all together, but there's multiple. So that's what's happening here. He's giving you some that are kind of pre-factored. Let me fix this line here, and let's go down and look at another example. Let's go do a tangent. We haven't done a tangent yet. So let's take a look at tangent. So similar to the one that we just did, we are going to say either tangent x minus 1 is equal to 0, or root 3 tan x plus 1 is equal to 0. That means either tangent x is equal to 1, or tangent x is equal to subtract the 1 over and divide by root 3. Make sure you're doing your signs correctly. I think I'm good there. And so as we look at this one, this might be not as recognizable. We have to rationalize negative root 3 over 3, and we just have to think for a moment. Certainly we know when tangent x is equal to negative 1, that's a pi over 4 reference angle. Now, where is tangent positive? First and third quadrant. So we're going to keep that pi over 4, and then we're also going to go pi over 4 beyond 4 pi over 4, or 5 pi over 4. Excellent. So we got two of our answers. We're going to have 4 ultimately coming through here. Now, root 3 over 3. I don't have my tangents memorized. I do know that sine of pi over 6 is 1/2, and that cosine then of pi over 6 is root 3 over 2. And I do know that tangent sine over cosine, and if I think about that, that's going to be my guy. Because when I take 1/2 and divide it by root 3 over 2, the root 3 ends up on the bottom, which is what I want. And so this is a pi over 6 reference angle, but in the appropriate quadrants. I need it to be negative. And so where is tangent negative? In the ones I haven't circled. So I need a second quadrant angle, no problem, 5 pi over 6. And a fourth quadrant angle, also no problem, 11 pi over 6. These are your answers. Those are your 4 answers to that single number 9 problem. And so you can see that we're going to continue to do this work. So it's pretty much the last section kind of on steroids, but there's some things to pay attention to here. And I've grabbed types of problems like this for your exam. Your exam will mirror your homework. Let's look at number 12, and then we will look at some other ones. So number 12 has us do 2 cosine x minus 1 equals 0. And root 2 sine x plus 1 is equal to 0. So that means cosine x is equal to bring over the 1, so it's going to be a plus 1, divide by 2. And I know, and you know, where cosine x is 1/2. That's at a pi over 3 reference angle. It's where cosine's positive. That's in the first quadrant. Always the first if it's positive, and also the fourth. So we're looking at the answers of pi over 3. I'll just label this as the reference. And in the fourth quadrant, 5 pi over 3. Now we need to know where sine x is equal to bring over the 1, negative, divide by that. So when was sine x equaling negative root 2 over 2? Easy. We know where that was. That was at a pi over 4 reference. A pi over 4 reference where sine's negative. Sine's negative in the third quadrant, so that is 5 pi over 4. And in the fourth quadrant, which is 7 pi over 4. And so our answers are all of these guys right here. Notice in that second one, the reference angle was not part of the answer because of the negative sign. Anytime if there is a negative in there. So let's take a look at something like number 13. This is a little bit different, but still doable for us. We would want to use the square root property. It can be handled in one of two ways, but let me use the square root property. So if I go here, we have, let's solve for sine theta. Sine squared theta, oh, sorry, it's not theta in this case, it's an x. And they have that there for a reason. We would move over the 1, positive, because we're going to add it to the other side, divide by 4. So I'm skipping over the algebra. If you're ideally, you can follow it. You've been through the algebra courses. You've chosen a major that's heavily algebra based. So you know how to get this to be sine x. You're going to go take the square root of both sides. But the one thing to remember is with the number, it's like every other algebra class. If you're the one to put that square root on, you have to do plus or minus. So we're going to get off of this left-hand side sine x, and off of the right-hand side for emphasis, plus or minus 1/2. So it wouldn't matter if it's positive or negative 1/2. We just need the angle that will get us there. Well, we know that the sine of pi over 6 is 1/2. So that's our reference angle. Well, you need a pi over 6 reference angle in every quadrant. So you're going to have pi over 6. Next quadrant is going to be 5 pi over 6. Then a 7 pi over 6. And then an 11 pi over 6. You have one in every quadrant because you could be positive or negative. So remember that on the exam. If you have a squared involved, you typically get 4 solutions. Certainly double what you would get. You get both the positives and the negatives. And you can see that this continues for a while. So let's use something like this cosecant. We haven't done a cosecant yet. So let's look at number 16. Let's do what we know we should. Solve for the trig function. By moving over the 4, it's going to be positive. Dividing by 3. Now we're going to go take the square root of both sides. Remembering always to put the plus or minus. And so as we do that, we come up with cosecant x is equal to, and again I'll put it in red just for emphasis, plus or minus 2 over root 3, or 2 root 3 over 3. So we got to think about that. Cosecant is the flip of sine. And so I got to think about who would give me that. If I flipped a root 3 over 2, that's where that would come from. So I'm really asking myself, okay, that's cosecant's the flip of sine. The flip of 2 root 3 over 3 is root 3 over 2. Whose sine is root 3 over 2? Easy. Pi over 3. Sine of pi over 3 is root 3 over 2. And so it's a pi over 3 reference angle in every quadrant. Now why is it in every quadrant? Because of the plus or minus. And so what do we have? Pi over 3. 2 pi over 3. 4 pi over 3. And 5 pi over 3. Okay, those are the 4 answers that are coming out of that. So you can see that that continues for a while. Now let's look at ones where we have to factor ourselves. So when you're given one like number 19, you're going to think, oh, I got to factor. You have to remember that you can't divide by anything. If you have something that's algebraic in nature, your really only way to do it is to ideally factor and set each of the factors equal to 0. So if you look at number 19, if I make that big and the only thing that we see, we can pull out a sine x. And if we do so, we get 2 sine x minus 1 is equal to 0. And you're right back to those earlier problems where you're setting the first factor equal to 0 and the second factor equaling 0. Well, let's take a look at that second factor equaling 0. We would move over the 1 and divide by 2. These are easy for us. Sine x equals 0. Sine corresponds to the y values. Where are my y's 0? At 0 and at pi. That's where my y's are 0. If I go around there, remember, that's at 0, 1. I'm sorry. have that backwards again. I did that earlier. 1, 0 and negative 1, 0. My y's are 0 at those 2 points. That's where the 0 and the pi are coming from. And then sine x equals 1/2, equally as easy. We have memorized that sine of pi over 6 is 1/2. And so we know it's pi over 6 because it's positive. The reference angle is pi over 6, but it's positive, so it's the first quadrant and also the second quadrant. And we're finished with those 4 angles. It doesn't matter to me if you list them in order or not when you answer the questions. And so that's what's happening. We could go through each one of these and realize, oh, that's easy. Let's go do a cotangent. We haven't done a cotangent yet. Again, what are we going to do? Factor out a cotangent. Cotangent x. That leaves me a cotangent x plus root 3. And so is equal to 0. So that means either cotangent x is equal to 0 or cotangent x, cotangent x plus root 3 is equal to 0. I don't know why I hesitated. So cotangent x is equal to 0. Well, we got to figure out where that's happening at. And then cotangent x plus 3 is equal to 0. That's when cotangent x is equal to negative root 3. So these take a little bit of investigating for me. I know that cotangent, so I'm going to, with 0, I know it's going to be at one of the sides. So let me label these properly. 1, 0, 0, 1, negative 1, 0, 0, negative 1, just moving around. I know that cotangent is cosine over sine. Well, if it's cosine over sine, then it's x over y. And so I need my, if I'm going to get a 0 out, I need to have my x be 0. So cosine corresponds to an x of 0. That's happening at pi over 2 and at 3 pi over 2. So those are 2 of my answers now. Pi over 2 and 3 pi over 2 for this number 22. Now when I go to answer the cotangent x is equal to root 3, I'm also remembering that cosine or cotangent is cosine over sine. And now I'm thinking, well, who's going to give me a root 3? Well, I know that the cosine of pi over 3, well, let me think about that differently. I know the sine, well, cosine, let me go back to cosine. I know the cosine of pi over 6 is root 3 over 2, and the sine of pi over 6 is 1/2. So I know that pi over 6 is legitimately, could possibly give me a root 3 over 2. If I divide those, yeah, it leaves the root 3 up top. So we have a pi over 6 reference angle. And you're just arguing through like that. However you did it in your trigonometry class that you passed to get into this one. So I need a pi over 6 reference angle where cotangent is negative. And that would be in the second quadrant and in the fourth quadrant. So we're looking at 5 pi over 6 and 11 pi's over 6. Those are your 4 angles coming out that way. So you can see that we have a little bit of a algebraic challenge here for you. Oh, we got trinomials to end out with, right? On the last page, let's look at least one of those together. Let's go to sines. Maybe you have sines memorized. Expect to spend a little bit more time on those areas where you don't have memorized as well. So this absolutely should factor. If it doesn't factor, we're really stuck because going to a quadratic formula is not so fun. And so you'll find that they're pretty nice to you even in your calculus class. But they'll just throw this in there with no explanation and just assume that you can do this part of a larger problem. Well, this does factor. You know that there's factors of 2 that add to be 3. And so it's going to be a 2 sine x and a sine x. And it's going to be a 1 and a 1 and both positive. We know you know how to factor. We know you're in a world of hurt if you don't know how to factor going into calculus. So that is the factorization. If we were to expand it, we would get exactly what we wanted. So where are we? Right back to the beginning of this section. And all we need to do is find out where 2 sine x plus 1 is equal to 0, or where sine x plus 1 is equal to 0, or where 2 sine x is equal to negative 1, or sine x is equal to negative 1/2, or where sine x is equal to negative 1? Well, we know that pi over 6 is the reference angle for a sine being negative 1/2 by our memorization. We also know that sine is negative in quadrants 3 and 4. So we need a pi over 6 reference angle in quadrant 3. No problem. That would be 7 pi over 6. And in quadrant 4, 11 pi over 6. Those are two of our answers. Now, sine of x equals negative 1. Sine corresponds to the y's. So this has a y height of 0. This has a y height of 1. Neither of those are our answers. This has a y height of 0, but this has a y height of negative 1, and so it's also a 3 pi over 2 from the visual there. That's what you're doing in 6.4. I apologize that there was no formal lecture, but hopefully this will suffice for that.